Friends, this is B. Praveen Kumar, lecturer in chemistry, JDC, Gambhirapet, Rajanna Srisilla district, Telangana. I am going to discuss about NMR spectroscopy, especially proton NMR spectroscopy. As we know, what is proton NMR? Let us see here. NMR, nuclear magnetic resonance spectroscopy. The spectra which is used to elucidate the structure of an organic compound. So, the nucleus of hydrogen atom or proton behaves as spinning bar magnet because it possesses both electric and magnetic spin. If we take a spin magnet or spinning bar, it is especially, we can explain the NMR spectroscopy, the nature of NMR spectroscopy with the bar magnet, as it possesses electric and magnetic spins. Like any other spinning charged body, the nucleus of hydrogen atom also generates a magnetic field. Nucleus of hydrogen atom generates a magnetic field. Nuclear magnetic resonance involves the interaction between an oscillating magnetic field of electromagnetic radiation and the magnetic energy of the hydrogen nucleus or some other type of nuclei. When these are placed in an external static magnetic field, the sample absorbs electromagnetic radiation in radio wave region at different frequencies. Here we can see which radiation can absorb in the NMR spectroscopy means the electromagnetic radiation in radio wave region at different frequencies, since absorption depends upon the types of protons or certain nuclei contained in the sample. Consider a spinning top. It also performs a slower waltz-like motion in which the spinning axis of the top moves slowly around the vertical. Here the radiation has to be electromagnetic radiation in radio wave region. So then this is called as precessional motion, the which motion is that maintaining the top, that is called as precessional motion, and the top is said to be precessing around the vertical axis of Earth gravitational field. The precision arises from the interaction of spin with Earth's gravity acting vertically downwards. It is called as gyroscopic motion. I repeat, the precision arises from the interaction of spin with Earth's gravity acting vertically downwards, which is called as gyroscopic motion. The precessional frequency may be defined as the number of revolutions per second made by the magnetic moment vector of the nucleus around the external field H0. H0 means precessional motion. The precessional frequency may be defined as the number of revolutions. Revolutions means the rotations, nothing but rotations per second, revolutions per second made by the magnetic moment vector by the nuclei around the external fields. Alternatively, the precession frequency of the spinning bar magnet may be defined as equal to the frequency of electromagnetic radiations in megacycles per second necessary to induce a transition from some spin state to another, one spin state to another. So here the both definitions are there: gyroscopic motion, precessional motion, and also precessional frequency. So here, if a proton is placed in a magnetic field, then it starts precessing at a certain frequency in the radio wave region, and thus will be capable of taking up one of the two orientations with respect to the axis of external field. Here you can see the two orientations, that is, one is alignment with the field and alignment against the field. Here two precisions, two situations, or two particularly two motions are there: alignment with the field and alignment against the field. That with respect to the axis, two orientations are there. Here, relaxation process. What is relaxation process? In NMR spectroscopy, relaxation process involve some non-radiative by which a nucleus in an upper transition state returns to the lower spin state. Relaxation process is called here. The nucleus in an upper transition state returns to the lower transition state. It is called as relaxation process. Two kinds of relaxation processes are there. One is spin relaxation, and another one is spin lattice relaxation. Here we can see it easily. If the relaxation process involve non-radiative, which a nucleus in an upper transition state returns to the lower transition state. two kinds of relaxation processes: spin relaxation and spin lattice relaxation. Okay. In NMR spectroscopy, the important point is shielding and de-shielding effects. Here, hydrogen nuclei in a molecule are surrounded by the electronic charge which shields the nucleus from the influence of applied field. Here the two fields are there: applied field and induced magnetic field and applied magnetic field. Applied magnetic field is the external field and induced is the internal field. If there is a hydrogen nuclei in the molecule are surrounded by the electronic charge which shields the nucleus from the influence of applied field. Thus, to overcome the shielding effect and to bring the protons to resonance greater, etc., our external field is required. Clearly, greater the electron density around the proton, greater will be the induced secondary magnetic field, which oppose the applied field, and thus greater external field will cause proton absorption. So this is the shielding and de-shielding effects. Here we can see the chemical shifts. Chemical shifts, for chemical shift that is, there is a reference compound, that is TMS, that is tetramethylsilane. Tetramethylsilane is the reference in NMR spectroscopy for calculation of chemical shift. If the delta value of chemical shift is 0, if you take a 0, from 0 the delta value of TMS is 0. If you take from 0, how much the compound is shifting, or how much far the compound will be, that is the chemical shift of a compound, an organic compound. Here the values of the delta values is there, some of the delta values here cyclohexane, that is 0.2, the primary hydrogens, that is 0.9, estolinic hydrogens or estolinic protons 2 to 3.5, vinylic protons 4.6 to 5.8, aromatic protons 6 to 9, alcoholic protons 3.4 to 4, ethers 3.3 to 4, ester 2 to 2.2, acids 2 to 2.5, aldehydes 9 to 10. So these are the delta values of different compounds. Next, we come to factors influencing the chemical shift. As we have seen, the chemical shift values, that is indicated by the delta. Here the factors influencing chemical shift. The factor influence the chemical shift is inductive effect, van der Waals de-shielding, anisotropic effects, and hydrogen bonding. Here in one sentence we can say it as: greater the electronegativity of the atom or group, greater will be the shielding effect on a proton. Greater the electronegativity of the atom or group, greater will be the shielding effect on a proton. Okay, so this is the main theme in the chemical shift. So these are the applications of NMR spectroscopy. Here we can see it. We can see the main applications. I'm not involving in each and every aspect. I'm just giving the outlines of the applications here. Especially the identification of disused in the identification of structural isomers. By using the NMR spectroscopy, we can identify the structural isomers here. Second one is detection of hydrogen bonding. So we can use the NMR spectroscopy to detect the hydrogen bonding. Detection of aromaticity. We can easily find out whether the compound is aromatic or aliphatic. So we can use the NMR spectroscopy for the detection of aromaticity. Next, distinction between cis trans isomers and conformers. Here, the to differentiate or to distinguish cis and trans isomers, we can use the NMR spectroscope. Detection of electronegative atom or group. We can use NMR spectroscopy to detect the electronegativity atoms or groups in a compound. So by using this, you can usually recognize the electronegative atoms. So detection of some double bond character due to resonance. Due to the resonance, we can identify the double bond character here. Next, last, importance in quantitative analysis. So NMR spectroscopy is much important in the quantitative analysis. So these are the main applications here. So by this I conclude the basic principles of NMR spectroscopy. So we should definitely we should remind the NMR spectroscopy, basics of NMR spectroscopy. We have to use the electromagnetic radiation in the radio wave region, that only the substances absorb the radiation and forms the NMR spectroscopy. So it is the basics. We have to convey one important thing here. The spectroscopy leads to the number of peaks or number of signals here. We'll discuss in the another topic. Okay, thank you.